Hello everyone. So we are going to discuss one more question from this assignment 4, quiz 4 of the NPTEL course Introduction to Machine Learning. So the question is this question number 2. So what this question is asking here, this is the question here. One dimensional data set is given. Okay, so if it is one dimensional data, that means I only have the x coordinate. Okay, so the x coordinate is given as what? -1, 0, 2. So let me just some point specify. This is 0, this is 1, this is 2, this is 3, this is 4. Likewise on the left hand side I will be having -1, -2, -3, -4, something like this. Okay, then x is nothing but this x coordinate, the x values that I have shown. These are the feature value, and y, here y is the output. That means if the data point is -1, so this particular point is -1. If the data point is -1, then the class level for this data point is what? +1. Okay, then if the data point is 0, if the data point is 0, okay, the class level for this data point is what? It is, this data point, it is -1. Then if the data point is 2, then 0, 1, 2, this data point, that means the class level for this data point is what? +1. So that means this data point, the circles are representing the positive data points, whereas the star is representing the negative data points. Okay, now the question is that true or false, the data set becomes linearly separable after using basis expansion with the following basis function. Some 5x is given, 1 x square. Okay, so this x data, when I am plotting the original data set, okay, then this data is not linearly separable by one hyperplane. Okay, by the hyperplane given by the SVM. Okay, so what it has, this question is asking that if I transform this data when using some kernel function, okay, if I transform the data into a higher dimension, then whether at that time it will be linearly separable or not. Originally it is not linearly separable. Okay, so after doing this basis expansion, the same data will be represented as, this is suppose is the data, okay, x, then basis expansion function is 5x. Okay, so when the data point is -1, okay, basis expansion is what? 1 and x square, so it will be 1, I'm representing it horizontally, 1, and -1 whole square will be what? 1 again. Yes, then if the data point is what? If it is 0, then after the basis expansion it will be 1. This 1 is coming from this 1, and 0 square will be what? 0, right? Then if the data point, the third data point is 2 data point 2, then after basis expansion it is 1, then 2 square will be 4. Now I will be plotting this 5x data. Okay, this is now a 2-dimensional data, and when I will plot this data, since this is a 2-dimensional data, I'm trying to have a 2-dimensional coordinate system. So in the x direction, it will be the 5x first point. Okay, first the point from the first column, and this point will be the second point. Okay, I'm just representing like that. So now what happens? Okay, let me again write the class levels. This is the positive class level. This one is negative class level. Okay, positive class level. This one is negative, and again third one was positive class level. From the data set I am writing it. Positive, negative. Okay, so I will be now plotting these data. So what is the value? Let me just mark some points here, okay, for my reference. The maximum value is 4, so only up to 4 I am marking here. Okay, so now if I plot the point 1, 1, then it will be what? 1, and then y, this in the y coordinate also it is 1. So this is the data point, okay. And what is the class of this data point? Class 1. So I will be representing it with a circle. It is the class 1 data. Then 1, 0, 1 and 0. Y coordinate system is 0. So again this same data point. What is the class level of this data point? Negative. So negative data points I am representing with a star. So this is the negative data. Then the third data is 1, 4. 1 again, and then 1, 2, 3, 4. Somewhere here it will be. And what is the class level of this data point? It is again positive, right? Now the question is, state true or false, the data set becomes linearly separable after using the basis expansion. Yes, now you can see that these data can be separated with a linear decision boundary, because the negative data point is in one side and both the positive data points are on the other side, right? So I can have a linear separator or linear decision boundary after expanding with this decision basis function that they have given. Okay, so the answer will be true. Okay, that is only this asking. Thank you.